Okay, so let's chat about correlation. Okay, so scatterplot measures, a scatterplot displays the strength, direction, and form of the relationship between two quantitative variables. Linear relationships are important because a straight line is a simple pattern that is quite common. Okay, a linear relationship is strong if the points lie close to the straight line. It's weak if they are widely scattered about the line. So far everything that we've seen has been relatively strong because we haven't really seen anything that has deviated much from that linear pattern that we notice. Unfortunately, our eyes, however, they're not very good at judging how strong a linear relationship is. Okay, sometimes it's easier than others. Okay, but definitely, we can make a comment on whether we think it's strong, moderate, or weak. But ultimately, our eyes are not the best judge of that character. So, in order to help us, we have our correlation. So our correlation R measures the strength of the linear relationship between two quantitative variables. Okay, so R is just a number. Okay, it's always going to be between -1 and 1. Okay, when R is greater than 0, it indicates a positive association. Less than 0, it's going to tell us that there is a negative association in our scatter plot. The values near 0 is going to imply that it's a weak linear relationship. Okay, the closer to 1 or -1 increases the strength of your relationship. Okay, in extreme cases where R is -1 and 1, that would be a perfect linear relationship. It doesn't happen too often, but it is definitely possible. Okay, so let's kind of take a look at what these might look like. Okay, so not much going on right here. Okay, I don't really see a linear pattern whatsoever. There is your weak correlation of 0. Okay, you could kind of sense that you have a bit of a negative correlation here. Okay, or a negative association rather. You don't really see much of a linear pattern, however, but you can definitely see that these are kind of going downward. Okay, so that would account for the negative correlation value. Okay, the 0.3 is indicating that it's fairly weak, but you can describe it as being moderate if you want. Okay, but I would say it's definitely moderate to weak. Okay, this is perhaps a little bit better. Okay, this one changes kind of direction here, so now we're looking more in the positive direction. Okay, it's not completely linear either, though. Okay, I mean, where do you put your line? Okay, so there is somewhat of a direction that's going in the positive direction, but not the best strength here. So as far as strength is concerned with this one, with a 0.5, I would say moderate. Okay, it's perhaps a little bit better than your 0.3. Okay, 0.7, so now we're getting a little bit stronger. Okay, so now this one I would say moderate to strong for your 0.7. And again, this is looking like it's downward again. Okay, so this is a negative association here. Okay, getting a little bit stronger, but still not the best. So we would say moderate to strong. Okay, this is a strong relationship right here. Okay. Definitely a positive, okay? You're not looking at much deviation from your linear pattern, okay? And this is extremely strong, okay? And that would be a negative association, okay? The strength there would be very strong, okay? Here, fairly strong. So I'm going to say fairly strong, very strong. Okay, moderately strong. This I would say moderate to weak. This is building up strength, so this one would be moderate to strong. Okay, this is a very weak association. Very weak in strength. Okay, so here's that scatter plot of SEC football. Okay, so we already saw the scatter plot, but we haven't really talked much about it. Okay, so we talked a little bit. Well, we actually talked a lot about it. We talked about it being a fairly strong positive linear relationship based on the idea that positive direction, okay, and not much change or much distance from your points to that linear pattern, okay. So we said it was fairly strong, okay. I go on now to tell you that the correlation is 0.936, okay. So this is just going to pretty much confirm what we already saw, okay. An R value as big as 9.36 is confirming, one, that it's positive, and two, that it's pretty strong relationship between the points per game and the wins in the SEC. Okay. It says the highlighted point in red, so let me figure out what point that is. Okay, this one down here is highlighted, so let me take that away. Okay, so that highlighted point right there. What effect is that is representing Mississippi? Okay, so what effect does Mississippi have on your correlation? So Mississippi makes the correlation closer to 1. If Mississippi were not included, the remaining points wouldn't be as tightly together in that linear pattern as it is, okay? So that kind of almost like starts off your pattern there. If that wasn't there, so if you could kind of ignore the existence of that, okay, it's not as good, okay? You kind of don't know where the pattern goes, okay? So it's definitely that point there that is making it stronger. Not that it wouldn't inevitably be the same interpretation, but it is making it slightly stronger. Okay. So let's talk quickly, and very quickly, about the idea of calculating your correlation, okay? So, yes, there is a formula to follow, okay? It looks like this, okay, which you can see is very long and can be extremely time-consuming, especially given that our data sets are not just 3 numbers, okay, but often they are quite lengthy, okay, and so to actually calculate this by hand is something that we're never going to do, okay. This will be the first and only time that you're going to see me calculate it, and it's the first and only time that you're going to do it yourself in this class, okay. We'll always rely on our calculator. Next class I'm going to teach you how to find scatter plots and all the information that you need for it on your calculator, but I'm going to do that in class, okay. So let's just take a look at it really quickly. So I'm going to keep going with that SEC football problem, okay? So let's see, the first team was Alabama, right? Okay, so I'm going to start off with 1 over my 12, I have 12 numbers here, okay? I put everything into my calculator. I got a mean of 27.07 and a standard deviation of 7.16 for my points per game. And then for my wins, I got a mean of 8.08 and I got a standard deviation of 3.34. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, I had 12. Okay. So that's the beginning part, my n minus 1. Okay. And then it's Alabama scored 34.8, a mean of 27.07. Okay. A standard deviation of 7.16. Okay. Alabama's wins. 12 minus its mean over its standard deviation. Plus, okay, next up is Arkansas. I have to go down a level here. write smaller here. Alright, here we go. So now I'm looking at Arkansas, okay? So 36.8, the mean was 27.07. This is points per game, okay? The wins, 11 minus 8.08. Mean wins were 3.34 plus. Okay, I'm gonna go last higher over here. Okay, those last people were Vanderbilt, okay, or last team was Vanderbilt. Okay, over the standard deviation, and then 6 minus the 8.08 over 3.34. Okay, I mean it's exhausting just writing out 3 values. Okay, imagine if I had to write out all 12, let alone go ahead and do all these tedious calculations. We're never going to do it, okay? We're always going to use our, this is going to get you down to that 936, okay? But we'll always just use our calculators, and I'll show you that when we get there. This is a formula on our formula sheet, so next class we'll also mark that up, okay? So that's it for this video. One more, and we're done with this, guys.